Welcome to the CoSpace robot family. Today, we will be introducing you to CoSpaceRobot Rescue. CoSpaceRobot is an official platform for both RoboCupJunior Rescue Simulation and RoboCup Asia-Pacific CoSpace Challenge. Please visit our website to find out more. In artificial intelligence, search techniques are universal problem-solving methods and are a very important component of AI. It has many important uses and applications, so do look them up when you get a chance. CoSpaceRobot Rescue is designed to allow users to learn search techniques in a 3D environment from scratch. CoSpaceRobot will give you a unique first-hand programming experience in this and many other applications. In the CoSpace Rescue U19 online challenge, participants have to develop and program appropriate strategies for a virtual autonomous robot to navigate and collect objects in a virtual world. The game will last for 6 minutes. This game will only take place in Virtual World 2. The blue robot will be used to complete this challenge. The red robot will be removed. A team will gain points by collecting objects. Please refer to the slides for more details. There is no penalty in the iCool challenge. During the whole entire game, 3 relocations are allowed. The robot will be frozen for 10 seconds after each relocation. One super object will be generated when one set of red, cyan, and blue objects are deposited together at one go. One super object is worth 90 points. One super plus object will be generated when 2 sets of red, cyan, and blue objects are deposited at one go. One super plus object is worth 180 points. The CoSpace server will send the position information of the super or super plus objects to the robot when they are generated. This signal will last for about 1 second, and the robot will only get the points when it picks up the super object. The dimension of the field is 360 by 270. The robot's current position on the screen is position X equals to 180 and position Y equals to 197. To successfully collect objects, the robot needs to use any one of the RGB sensors to detect the object. RGB stands for red, green, and blue. Stop for 3 seconds with LED flash. Set key action. Find objects. To successfully deposit objects, the robot needs to use both RGB sensors to detect the collection box. Stop for 3 seconds with LED on. After depositing, leave the deposit box automatically. Set key action, deposit 1 or deposit 2. Deposit 1 means moving backward after depositing. Deposit 2 means moving forward after depositing. Hello, good job, we are almost there. Let's select CoSpace Rescue U12 in the subleague and choose CoSpace Rescue U12 map in the library. We'll run it to see if our computer is compatible with this software. While we're at it, let's also check and see the version of our software. It's always good to have the latest version. Awesome, it seems that our computer is compatible and our software is up to date. The activation window has just popped out, so please make sure you're connected to the internet and input your account number as well as your serial code, which is also your license number. So these will be given to you via email, so please make sure to check your email. And also please make sure when you put in your serial code, there are no spaces in the front and at the back, because the serial code is case sensitive. And if you're having trouble with the software, you should right-click on the icon and click the Run as Administrator option. Let's start your first program. Launch CoSpace Rescue Simulator by double-clicking on the icon. Select the correct subleague, content library, and competition map for the iCool challenge. Programming a robot consists of three elements: sensing, planning, and action. Let's take a look at the CoSpace Rescue Virtual Robot. It contains the following sensors: 2 color sensors to sense the floor RGB color. RGB stands for red, green, and blue. 3 ultrasonic sensors to sense the obstacles on its front, left, and right. 1 compass sensor to sense the robot's orientation. For the robot's actuators, it contains 2 wheels and 1 LED for status indication. Participants have to plan and program strategies to control the robot so that it can collect more points. Click on the 3D environment. Now you can use the direction keys to manipulate to your preferred point of view. Click on the control panel and you will be able to control your robot using the direction keys on the computer keyboard. From the control panel, you will find live sensor data. What is the logic behind the robot's thinking process when it collects objects? The 2 color sensors mounted on the robot will let the robot know what kind of object is underneath it. And then the robot will take corresponding actions according to the sensor readings. So the first thing we need to do is to know the color of a particular spot on the map. We need to record the RGB readings of different objects. If no program is loaded into the robot, you can use Minimap, Virtual Joystick Controller, and keyboards to control the robot. Black color RGB reading is 39, 39, 39. The collection box is orange in color. Traps are surrounded by a yellow boundary. Let's code a navigation program in CoSpaceRobot. Double-click on the AI button to enter the programming interface. On the top of the programming interface, you will find some file management buttons. First of all, you will need to create a new project. Click on the New Project button. Please remember to give this program a team ID, a team name, a project name. Remember, once team ID and team name are confirmed, they cannot be changed anymore. However, you can change the project name if you wish. First, we need to switch to World 2. For CoSpace Rescue U19 iCool challenge, participants only need to program World 2. As you can see, there are many statements in one program. Conditions are inputs from the environment. Actions are outputs to control the robot. The priority is set by statement order. The higher the statement, the higher the priority. We will start from a basic navigation program with 4 statements. A good navigation program can help the robot complete a more efficient search. The first statement should tell the robot to move forward if there is no obstacle. The second statement should tell the robot to turn right if there is an obstacle on the left. The third statement should tell the robot to turn left if there is an obstacle on the right. The fourth statement should control the robot appropriately if there is an obstacle ahead. After the statement name is defined, we will add conditions to this statement. Statement turn right. There's an obstacle on the left. Let's set the condition as ultrasonic left is smaller than 12 and let the robot turn right. Statement turn left. There's an obstacle on the right. Let's set the condition as ultrasonic right is smaller than 12 and let the robot turn left. Statement front. There's an obstacle ahead. Let's set the condition as ultrasonic front is smaller than 12 and let the robot turn right. Great! We have completed our first program. Once you have completed programming, it is very important to save and build. Now you can click on the blue Build and Test Project button to see how the robot will behave. This game will be single player only. The blue robot will be used to complete this challenge. The red robot will be removed. For CoSpace Rescue U19 challenges, there will be no boundaries in the virtual world. If a robot moves out of the boundary, it will automatically be placed inside the boundaries by the CoSpace server. However, it will be frozen for 10 seconds. Gray color areas in the virtual world are designated as swamplands. If the robot falls into the swampland, the CoSpace server will reduce the robot's speed by 80%. Participants are required to keep the robot within the virtual arena based on the dimensions given. The dimension of the field is 360 by 270. Use advanced conditions to keep the robot within boundaries. Position X is less than 10 or greater than 350, or position Y is less than 10 or greater than 260. If the conditions are met, make the robot turn around as if there is an obstacle in front of it. Now you can click on the blue Build and Test Project button to see how the robot will behave. Great! We have completed our first program. If you stop the program manually or if time is exhausted, the following dialog box will pop out. During the iCool challenge, you will need to save and submit the ICS file to the iCool challenge server. From our previous demonstration, we have learned how to navigate. Next, we will learn how to collect objects with color sensors. At the beginning of the video, we have manually moved our virtual robot over red, cyan, black, yellow, and orange colors on the map, and we have recorded the corresponding RGB reading from the color sensor. Because the robot has 2 color sensors, we need to calibrate them separately with different colors. After the statement name is defined, we will add conditions and actions to these statements. To successfully collect objects, the robot needs to use any one of the RGB sensors to detect the object. Stop for 3 seconds with LED flash. Set key action. Find objects. Red token's RGB reading is 255, 35, 35. We'll set a range to include these values as conditions, and set actions accordingly. For both the left color sensor and right color sensor, we will now calibrate the left color sensor for cyan objects and set an appropriate action. We will now calibrate the right color sensor for cyan objects and set an appropriate action. We will now calibrate the left color sensor for black objects and set an appropriate action. We will now calibrate the right color sensor for black objects and set an appropriate action. Because the maximum number of objects the robot can carry at any one time is 6, it is a waste of time if the robot is still trying to pick up objects after it is fully loaded. Let's add a restriction so that the robot will only pick up a token if it is not full. Advanced condition: loaded objects is less than 6. If the robot falls into a trap, all objects that have been collected but not yet deposited in the object collection box will disappear. When crafting your strategy, please pay attention to both offense and defense. Be balanced. Use the color sensors to avoid the yellow warning line. And set actions accordingly. The maximum number of objects the robot can carry at any one time is 6. So we can only pick up more objects after we deposit them into the orange collection box. Use both RGB sensors to detect the collection box. At the same time, if the robot is empty, there is no reason to waste time on depositing. The robot will only deposit tokens if it has more than 3 tokens on it. Advanced condition: loaded objects is greater than 3. Stop for 3 seconds with LED on. Deposit 1 means moving backward after depositing. Deposit 2 means moving forward after depositing. The CoSpace server will send the position information of the Super or Super Plus objects to the robot when they are generated. This signal will last for about 1 second, and the robot will only get the points when it picks up the Super object. We could use the debug function to monitor variable changes. Select Super Object Number, Super Object X, and Super Object Y. One set of red, cyan, and black objects on the robot. One super object will be generated when one set of red, cyan, and blue objects are deposited together at one go. One super object is worth 90 points. The robot will only get the points if it picks up the super object. If a new super object is generated, the variable super object number will be set to 1. You will get super objects X and Y position at the same time. However, this value can only last for about 1 second, after which these values will reset. The robot will only get points when it picks up the super object. In that case, we will create 2 new variables to save the information of this signal, so that it can be used later. Click the VAR button to define new variables to store the information you need. Define as X to save superobject X with an initial value of 0. Define as Y to save superobject Y with an initial value of 0. Create a new statement to save superobject X and superobject Y. If superobject number is not 0, we'll store superobject X and superobject Y into SX and SY respectively. Now, let me show you how to create conditions and actions to pick up superobject and superplus object. Right color sensor. and left color sensor. Condition: set loaded objects to be less than 6 in advanced condition and action. Don't forget to reset SX and SY to 0 after you pick up Super or Super Plus object. Now you can click on the blue Build and Test Project button to see how the robot will behave. Gray color areas in the virtual world are designated as swamplands. If the robot falls into the swampland, the CoSpace server will reduce the robot's speed by 80%. Think about how to avoid or resolve this problem. In the virtual world, there are 3 signal block zones surrounded by dotted lines. These signal block zones are randomly created by the CoSpace server. They will be generated once the field is launched. The location of the signal block zones will not change throughout the entire game duration. When a robot enters the signal block zone, its coordinates information will be blocked. This means that the robot will receive position x equals to 0 and y equals to 0. During the whole entire game, 3 relocations are allowed. The robot will be frozen for 10 seconds after each relocation. Second relocation. Think about how you're able to plan the robot's path so that it can complete a more efficient search. The robot needs to monitor for the superobject variables. Number of relocation has been exhausted, and the robot cannot be relocated anymore. One set of red, cyan, and black objects on the robot. One superobject will be generated when one set of red, cyan, and blue objects are deposited together at one go. One superobject is worth 90 points. The robot will only get the points if it picks up the superobject. The CoSpace server will send the position information of the super or super plus objects to the robot when they are generated. This signal will last for about 1 second, and the robot will only get the points when it picks up the superobject. We have stored superobject X and superobject Y into SX and SY respectively. As of now, you already know the location of the robot, superobject, deposit area, special area, traps, and 3D obstacles. Think about how you're able to plan the robot's path so that it can complete a more efficient search. And off we go! In this demo game, we will minimize any manual intervention. Red robot entered the black object area, and the black object is worth 20 points. Blue robot is searching in the blue special area. Any objects picked up in this area will double in value. Blue robot has a set of red, black, and cyan objects. It can generate a super object. Red robot is depositing. Red robot has picked up a super plus object. That is 180 points. Blue robot has picked up a super plus object. That is 180 points. Blue robot is depositing. Red robot is full. Red robot is depositing. Blue robot has a set of red, black, and cyan objects. It can generate a super object. Blue robot has picked up a super plus object. That is 180 points. Red robot is depositing. Blue robot is depositing. Red robot has picked up a super plus object. That is 180 points. Blue robot picks up super object. That's 90 points. Both robots are in the blue special area. Any objects picked up in this area will double in value. Red robot is depositing. Blue robot is depositing. Blue robot picks up super object. That's 90 points. 1 minute left. Red Robot has picked up a Super Plus object. That is 180 points. Red Robot is depositing. Blue Robot is depositing. Red Robot wins this challenge. Congratulations!
Hi, CoSpace fans from all over the world. I'm Huang Zixi from Shenzhen, China. I participated in CoSpace Rescue U19, and it is my honor to be here and share my experience with you. First of all, I want to talk about my interactions with robotics. Strictly speaking, I have involved in robotics for 1 entire year. It is not a pretty long time, but in this year, I developed strong interest in robotics field and frequently participated in various robotic competitions. I participated in my first formal robotic competition, VEX, last year. I met many congenial friends in the VEX team. We trained, cooperated, and prepared for the competition together. We had our first competition in Nanchang and won the first prize. We qualified for the Asian tournament and won the bronze award, which is not bad for our first try. Since VEX tends to be more related with hardware, I started to learn programming language and algorithms under my teacher's guidance at the beginning of 2020, and I participated in CoSpace Rescue and fortunately qualified for the final. By using CoSpaceRobot, I learned C language programming, robot control method, path planning algorithm, and optimal decision system design, which I had never been exposed to before. These knowledge were very fascinating, and I was deeply attracted by them. IQ Challenge brings me into contact with RoboCup, which is recognized as the first-class robot competition in the world, known for its rich competition events and its professional and leading nature. After watching the shared video on RCAP Academy channel, what I'm most interested in is the strategy applied by the participant Mark Jun Win. The path planning algorithm and the decision strategy designed by him are especially stable and efficient in the whole running process. I will share my knowledge of robot and artificial intelligence with my classmates and friends, and we can express and share our own distinct ideas and learn from each other to make progress together. Let's move on to the strategies I applied to program my robot. The strategy is called Dynamic Adaptive Search on Demand Algorithm. The algorithm consists of 3 most crucial and distinctive layers of strategies, which are state transition, path programming, and decision system, and I'm going to elaborate on each of them next. State transition method is based on the finite automata theory. In order to enable the robot to make corresponding reactions under different circumstances, we defined 8 states to help control the robot's behavior. All 8 states contain respective triggering conditions, ending conditions, and execute statements, and the robot can only be in one state at a time. The triggering statements and ending statements contribute to the switch between states under different circumstances, and the execute statements manipulate the robot's behavior under certain states. Floyd-Warshall algorithm, known for its brief realization and powerful function, is the core algorithm of the path programming process. Floyd algorithm enables the robot to calculate the shortest path between any 2 points on the field. The key principle of this algorithm is that if the path which passes through point K is shorter than the direct path between I and J, then update the value of distance between point I and J. Now we have the theoretical basis of Floyd algorithm. To implement it, we need the aid of topological mapping. Topological mapping can convert the graphical data into digital data by dividing the field into a number of rectangle zones, and categorize them into object zone, non-object zone, and collection box. The object zone is also subdivided by the color of the objects and labeled with the quantity of the objects, which will further contribute to the decision system. There are also feasible paths which connect different rectangle zones together. All the categories and coordinates of the rectangle zones are recorded and stored in the program, and these data allow the application of the Floyd algorithm and decision system. The decision system tells the robot which zone to search for depends on the current circumstances when the robot is in the search state. Multi-keyword sorting is the fundamental principle of the decision system. The three keywords in the sequence of priority are requirement, quantity, and distance, and we can get these data from topological mapping. When the robot is deciding, it first tests its current requirement for red, cyan, or black object and go for the corresponding zone. If the requirements are the same, then it will find the zone with the greatest quantity of objects, and if the quantities are the same, it will find the closest zone with object. Inevitably, we also encountered some problems when we are planning our strategies. The first problem is that when the robot enters the signal block zone, the robot loses the coordinates information. At this time, the robot will make an unexpected mistake according to the wrong coordinates. Well, the method to solve this problem is to make predictions of the coordinates of the robot in the signal block zone according to the coordinates, speed, and direction of the robot before it entered the signal block zone. The second problem is that many details of map information will be lost by using topological mapping, and the performance of the algorithm is closely related to the result of topological mapping. The solution to this problem is to divide the field into 360 times 270 of small grids and optimize the paths using the A-star algorithm. The A-star algorithm can effectively solve this problem. And the third problem is that when a certain type of object has a very small number in the field, the efficiency of the algorithm will be reduced due to the strategy of searching for RRCCBB objects. Well, I have to admit this is a prominent defect of my algorithm. There's no better way to deal with this problem for the time being, but I'm trying to figure it out in the future. At last, I sincerely appreciate for your patience of watching my sharing. Thank you.